we are looking at the performance of the central processing unit, there are a number of factors that need to be factored in order to actually figure out the speed of the performance in the CPU. Some of them are like the size of RAM you have. We have the size of the data bus. If the size of the data bus is big enough to transmit more data, then that one will affect the overall performance of the CPU. There's a number of other factors like the cores, the number of individual processors that a chip or a processor has. Okay, then there is also the cache, and there is also the internal clock. So apart from these three, we have other elements that determine the performance of the CPU, or generally the processors. Now let's look at the performance of the CPU and what are the key elements that are able to influence the performance of the central processing unit. One among the factors is what we call the clock speed, or the system clock. So the system clocks define the clock cycle that normally synchronizes all the operation of computers. Remember, we say that the control bus is used to transmit timing signals that is actually able to synchronize all the activities and the operation of a computer. Now, if you increase the clock speed in a way, you are able to increase not only the frequency but also the speed at which the computer is able to perform or execute instructions. For instance, if you have a processor that is 3.5 gigahertz, this translates to 3.5 billion clock cycles per second. Now, this is a very good performance. It is actually a performance that is considered good in the computer. And so if you increase the clock speed, technically you are also increasing the performance of the CPU. But that alone cannot generally improve the performance of the central processing unit. There are other factors which, if put together with the increase of clock speed, then the performance of the central processing unit can be greatly improved. Now, one among them, or one among the elements or factors that are normally considered, is what we call the width of the address bus. The width of address bus, and also that of the data bus. So if you have a 32-bit address bus, that one cannot be compared with a 64-bit data bus, because both are able to transmit data at different speed, and the amount of bits they are able to transmit now differs. So the computer with a 64-bit data bus is able to transmit more data, and also able to identify more memory location in that context. So when considering the performance of the CPU, we must also understand that the width of the address bus and that of the data bus also affect the general performance of the CPU. The other factor that is also fundamental or fundamentally important is what we call overclocking. Yeah, this is a factor that must be considered. Generally, you can go to your computer BIOS and alter the setting to improve the speed, but that one can interfere with the performance of the computer. Generally, if you interfere with the the way the BIOS has been structured, and you influence that by affecting it or altering it, the clock speed can go out of range of what the computer was designed for, and that can potentially bring your computer into some problems, because generally executing instruction outside the design limit generally can lead to unsynchronization operations, which can alter the performance of the computer and probably crash your computer. Then we also need to also look at overclocking can also seriously bring your computer to a serious overheating of the CPU, and that can lead to minimal performance, because normally the CPU is overheated and even the cooling system cannot cool it down. Then the computer will just stop working, and that will not be a very important. So it is important not to overclock in the quest to increase the performance of the computer. We should have the right kind of clocking speed for our computer. Then there is also the whole idea of cache memories. We know that we have in the CPU, we have the registers, and we also have the RAM, which is normally the workbench of the computers. But RAM is normally far away from the CPU. So technically, the time for a CPU to reference and to fetch data from RAM and use it in the CPU or use it for processing takes time. So it will take a CPU quite amount of time to access or to reference data from the RAM and make use of it. So there is what we call the cache memory. Now, cache memory is the memory that is located within the CPU itself. So its major function is to store frequently used instructions, so that when the CPU needs them, it doesn't need to fetch data as far as from RAM, but is able to get it from the cache and make use of it, and that will improve the performance of the computer in such a way, to a large extent, make the computer perform optimally, as compared to a computer that doesn't have computer that doesn't have the cache memory. Now, that is important to take note of. That is critical to understand at this point in time, because the computer must use RAM, or generally memory, to store both data, instructions, and also to make sure that during and after processing, this data have got a place where they can be stored and probably used in the CPU endeavors. So it is important to also make sure that you have enough cache memory within the processor, so that your computer speed can be greatly improved. Yeah, so because when you improve the speed of the processor, technically you are also improving the speed of the computers. Now, there are their use, the use of different cores, right? So the use of different cores, like in our current world, we have computers having more than one core. So one core is made up of one core is simply a processor that has got the arithmetic logic unit, control unit, registers, and buses. So when you have a computer that has more than one core, it means that this computer can be able to work optimally in executing tasks. So the thing is that the CPU that has many cores can be able to perform much better than a computer that only has one core. So currently we have computers which have more than one cores. We call them dual core. We have computers that have 4 cores. We call them quad cores. We have those that have got 8 cores. We call them octa cores. So they are mostly used on phones. The octa core kind of processor, they are normally used in phones currently. And the use of many cores in a small device like a phone has been able to transform how we communicate generally in our world today, because we've been able to bring in high performance in small devices, and therefore we can carry these computers wherever we are and be able to optimally fulfill our objectives and be able to improve our speed in executing and performance in our workplaces. So it is important to note that when a computer has more than one core, it can be able to perform optimally. Now, we normally have computers having more than one core. So normally these computers are able, these cores are able to communicate with both, or the CPU is able to communicate with the both core using one channel, reducing some of the potential increase in its performance. So with the quad core, the CPU communicates with all the core using 6 channels, considerably reducing potential performance. But at the end of the day, the key thing is to make sure that the performance of the computer is greatly improved. So there is one thing we need to understand here, that one core is made up of what I considered, what I mentioned earlier, the arithmetic logic unit, the control unit, and the registers. Then you have many computers have dual core currently. So we also have the ones that have 4 cores. We call them quad core. The octa core, which have the 8 cores. So however, doubling the number of cores doesn't necessarily double the performance, since we have to take into account the need for the CPU to communicate, which can reduce the overall performance. But in that, there is a sense in which having more cores are able to improve, so that the computers nowadays are able to actually consider the task at hand. And because they have many cores, the computer has many cores within it, it is able to assign the task to a certain core depending on how heavy the task is. Depending on how heavy the task is, what type of resources are needed. Now, if it is something that is not resource intensive and time intensive, so it will assign it to low performance core, because we normally have the high performance core and the low performance core. So the high performance core are always dedicated to those tasks that need a lot of processor time, a lot of resources in terms of maybe graphics. So if you are playing a game, maybe the gaming program and the graphics that is needed, all these tasks belonging to or related to gaming that you are doing are normally channeled to the high performance core. So in as much as sometimes considering the communication between the two cores, but there is a way in which the current computers have been designed in order to leverage the whole idea of having more than one core to make the computer performance experience fast and efficient. So it is important to take note of that. So that is very important to look at as it is now. So I think having stated that, it is very important to understand that when you are talking about the improvement, when you are talking about basically how to improve the performance of the computer, you need to look at a number of factors, not only the clock speed, not only the overclocking, not only the number of cores that are there, but also how efficient are these cores able to communicate in order to improve the general performance. So the general performance of computers is affected by various factors. So we can talk of the cores, the number of cores you have. The cache memory, right, which is right within the CPU, is also important because it is able to reduce data access times and even latency time of the processor. So all these factors put together, if they are put in right order and in right frequency, as far as the overclocking and the execution of commands are concerned, then the computer will be able to perform optimally and in a manner that will greatly improve your output as a computer user. So it is important to have that in mind even as we understand this concept. So I think today we have looked at those elements and we've said that computer performance is basically affected by these elements in a greater way. We will not only when we are considering the speed of the computer, we'll not only look at the clock speed, we'll also look at the size of the data bus and the address bus, because control bus are not they don't need to be such huge because their work is just to send signals. Now we are also going to look at the cache memory, the memory that is within the CPU, right? Then we also not only considering the clock time, but also the overclocking or the frequency with which the execution is done in the computer. So we need to have the appropriate clock speed so that we don't overclock our computer and crash it in due process. So we need to look at that, because most of us always ask themselves, how do I improve the speed of a computer? So that's how it is. Sometimes even adding more RAM or adjusting your amount of RAM to increase it will always improve your computer. So there are so many things that are considered when looking at the general performance of a computer. So thank you for taking your time and watching this video. Mine is just to encourage you, if this is the first time you are here, and or this is the first time you are watching, please subscribe, and if you've already done so, please